the disadvantages of using cylinder breaks, which is very common with destructive testing, is they're heavily reliant on proper sample preparation. And we require to use skilled labor in following those procedures. On top of that, that cylinder typically has to stay at the site for about 24 hours until it gets hard enough to transport it. If you transport it before it's hardened properly, the jiggling around and bouncing around in a transport vehicle, your car off of a job site or truck, that could cause problems in the cylinder not coming up to full spec. And then once you get the samples demolded and brought to the lab, they typically have to be kept wet and wet right up to the moment of testing to avoid inaccuracies. And a lot of people take the samples, they store them in a water bath environment at a constant temperature of 70 degrees. And then they take them out, they might dry them off, and then they might crush them later, but they're supposed to continue to stay wet. So there's a lot of ways that technicians don't necessarily follow all the process procedures that are required by the specifications. And in doing so, you end up with inaccurate results. Also today, we have many, many different new mix designs coming on board on ways to reduce the amount of carbon impact by reducing the amount of cement and adding in other additives. And those new mixes are finding that it's much more difficult to make accurate cylinders. Also, the aggregate composition significantly influences the way the cylinder is made and other variability. And aggregates can be anywhere from under an inch to as great as 3 inches in size. And so if you have large aggregates and you put it in the wrong type of compressive mold, you could have inaccuracies. So a lot of things can go wrong in making cylinders, and yet we use that in our operation every day to measure the strength.